Okay, in this episode, we're going to do some problems based on vector decomposition, unit vectors, polar formats, and Cartesian formats. Let's begin. Alright, in our first question, we have a particle which is moving due north at 5 meters per second. Alright, okay, so let's say the particle is over here, and it's moving due north this way at 5 meters per second. And it's subjected to an acceleration of 2 meters per second square due west. I'm going to use yellow for acceleration. So this is our west. 2.0 meters per second squared. We want to calculate its speed after 5 seconds. Well, let's try and first visualize what the motion is going to look like. Well, since it has a velocity along the north, I'm going to call along north as vertical, and I'm going to call along west as horizontal. Alright? So, since its initial velocity is along the vertical, it wants to go this way. But since it has an acceleration, it starts curving in this direction. That's pretty obvious, right? We want to know after 5 seconds has elapsed, what's going to be its speed? Well, we know that its velocity is going to be this way, tangential to the path. And how much is that going to be? Now, to answer that, what we will do is we'll decompose this velocity into two parts. This will be the velocity along the y direction, which is the vertical, which is the north, and this will be the velocity along the x direction, which we'll call as the horizontal, which is the west. Now, to solve this problem, we are going to use the fact that vectors have absolutely no effect in the perpendicular directions. So what this means is, if I look at the vertical direction, its velocity, acceleration has nothing to do with the velocity and the acceleration in the horizontal directions because they are perpendicular to each other. So I can use 1D motion separately in vertical and separately in horizontal. They live a life of their own. The only thing that connects them is time. So let's do it. So what we'll do is we'll look at vertical separately. Alright, so here is vertical. Vertical means along north, alright? Okay. Now, since there is acceleration is directed towards the west, it's horizontal. There is absolutely no acceleration in the vertical. It has no component in the perpendicular direction. Therefore, acceleration in the vertical is 0. Since acceleration is 0, final velocity will be the same as initial velocity. So it's going to just remain 5 meters per second. So our velocity along the y is just going to remain 5. That's not going to change at all. Let's now look at what happens in the horizontal. Horizontal is what I call as west. Notice now that all the initial velocity is only along the vertical. There's absolutely no initial velocity along the horizontal, again because that's because this 5 meters per second square, 5 meters per second over here has no component along the west direction. So initial velocity along the horizontal is 0. Acceleration along the horizontal, I'm calling this as my positive. I'm calling up as positive. So acceleration along the horizontal, well, that is 2. And the time taken is 5 seconds. Therefore, we can use Vx equal to ux plus ax into t. So final velocity is the initial velocity plus acceleration times time, which is 10 meters per second. Therefore, the velocity over here is 10. So we now understand that the final velocity along the vertical is 5, along the horizontal is x. So what's the total velocity? Well, we have to add them vectorially. And we have seen in last episode, how to do that. Okay, so just Pythagoras. So here is 5 and here is 10. We complete our parallelogram. And once we do that, Pythagoras will tell us that this v, the total speed, is going to be 5 square plus a 10 square. That is a square root of 125. This is our answer. Let's move on to the next question.